shut it down so we can talk here quick. Now let's take a look here at our dynograph. So we see it made 429 torque and 464, 465 horse. So very, very similar to what we found in the power when we were on speed density. Now we take a look here at our actual EQ ratio and the overlay. We are seeing that it's off here about 5-6%. So we need to go in and deal with that. Now if we take a look, I'm just making sure everything else looks correct here. It looks like the speed was dropping right here. I don't know if that was a logging problem or what. Okay. And spark timing is looking like it's the same. 28 degrees, 24 degrees. Now that means if we flip here to our spark retard table, we're pulling, or should be pulling, about the same spark air mass. Yeah, we're about 0.72, 0.76. We were pulling about 0.76 to 0.8. That's probably because we have this deviation here. Let's flip backwards here, EQ ratio. If we scale this out and we see that we're adding here about maybe 5 to 8%, 10% into our MAF curve, seeing we have our EQ ratio reporting that difference, if we're starting to correct our airflow modeling, let's actually take a look what the dynamic airflow or the mass airflow is showing. Dynamic airflow is what's coming from the mass airflow sensor. So let's actually scale this to a pound per minute. So we're finding here that it's showing 41. Previously, we're showing about 44, almost 45 pound per minute in the speed density mode. So if we scale this by what it's showing here, about 5-6%, it should get us back in line with the dynamic airflow and what's being reported from our actual mass airflow sensor in the curve. And then we'll find that everything else should fall in line here. Yeah, we see even the duty cycles dropped. And we should see our spark air mass kicks up into, again, where we were seeing it before, about 0.76, 0.8. But we do see the spark timing here is the same. If we actually take a look at our spark timing table, let's just close this quick. We do see that we're riding in this range here, so 0.72, 0.76. If we look, our spark timing is commanded the same here, between 0.72, 0.76, and 0.8. We were here versus here in the table, depending on, again, what we're looking at here, pool to pool in the different modes. So it's the difference of operating up a row essentially, and the spark timing is the same. That's why we don't see the power really deviating. Let's add our fuel. Let's do another pool again, and it probably is going to be nailed down at that point. Let's go airflow, frequency, airflow, and we're going to be shifting up to the higher frequencies here, into the higher range of the table, most likely from 6,000 and higher. We're going to be evaluating this. Let's go back in here to our scanner. So we're going to be starting off and really looking here. Let's go here about 6,000 and higher. So we're seeing a lot of 7%, 6%, 10%, 9%, 7, 5, 5, 6, all the way out here, 5, 4, 5. What I'm going to do is go from, let's say, 6750.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.